Hello everyone. In this video, we are going to discuss about the theorems related to quadrilaterals and semicircles using vectors. Welcome to Now Maths is Easy. Dear friends, if you are new to this channel, please do subscribe. And the existing subscribers are welcome back again. And everyone is requested to watch the video till the end so that you can understand all the concepts and basics which helps you gain good marks in the SE examination. So now let's take the first theorem. The first theorem is the lines joining the midpoints of the sides of a quadrilateral taken in order form or parallelogram, or the next words to this theorem is the figure formed by joining the midpoints of the adjacent sides of a quadrilateral is a parallelogram. Okay, so now let's see what does this word mean. We are given that the parallelogram we have, okay, so parallelogram we have a quadrilateral, not a parallelogram. This quadrilateral A, B, C, D we have, and there are the midpoints of these sides respectively. Let this be M, this is N, this is P, and this is Q. Okay, so we know that M and PQ are the midpoints. So let's say by using midpoint formula, okay, by using midpoint formula, we have OM vector equal to half of the vector of OA plus OB. Half of vector OA plus vector OB, this is number 1, and now we have ON vector equal to half of vector OB plus OC. This is number 2, and we have OP vector is equal to half of vector OC plus OD. OC vector plus OD vector, this is number 4, and now we have OQ vector is equal to half of OD plus OA. OD vector plus OA vector, this is number 3 and this is number 4. Okay, so now let's check the either sides like AM or PQ, or also we can say QM and PM, the opposite sides. So we are going to check the opposite sides, vector of these opposite sides, MN and QP. Let's check. So I have vector MN, okay, vector MN I have is ON vector minus OM vector, okay, so let me write it. And now I have QP vector is equal to OP minus OQ vector, okay, so let me write that as well. Now here I have MN vector equal to ON minus vector OM. So my ON vector is half of OB plus OC and OM is half of vector OB plus OC. Similarly, I have OP minus OQ and I know what is OP and what is OQ. So let me replace this ON, OM, OP, OQ with these vectors. Okay, so let's check what happens then. So from equation number 5, okay, 1, 2 and 5, what we get, let's check. Okay, I'm doing here from 1, 2 and 5. Okay, 5. My 5 is vector MN equal to vector ON minus vector OM. So my ON vector is half of OB plus OC, half of vector OB plus vector OC minus half of MN vector is half of OA plus OB, half of vector OA plus OB vector. Well, so now let's find out. Here I have half of vector OB plus half of vector OC minus half of vector OA minus half of vector OB. So OB vector and OB vector cancelled and I have OC minus OA. So half of vector OC minus vector OA. Okay, Mn equal to OC vector minus OA divided by 2. We can say, now let's check 3, 4 and 6. Okay, so from 3, 4 and 6, from 3, 4 and 6, from 3, 4 and 6. Okay, from 3, 4 and 6 we have QP vector is equal to OP vector minus OQ vector, and my OP vector is half of OC plus OD. So I'm going to write half of vector OC plus vector OD minus my OQ vector is half of OD plus OA. Half of OD vector plus OA vector. So it's equal to half of OC vector plus half of OD vector minus half of OD vector minus half of OA vector. Okay, minus OD plus OD vector cancelled, and finally I have half of vector OC minus half of OA. Taking half common, I get OC vector minus OA vector. So from here we see that this is also OC minus OA of half of OC minus OA, that is Mn vector, and here half of OC minus OA, that is QP vector. Okay, so from here we can say that this is the equation number 7 and this is equation number 8. Okay, so from 7 and 8 we have, from equation number 7 and 8 we get vector Mn is equal to vector QP, right? Then we say that therefore Mn is equal to QP and Mn is parallel to QP. Okay, here we can see that vector A equal to M times vector B. So M is a scalar, we can say Mn equal to 1 times vector QP. So these are the equal and parallel vectors. Hence we can say that if the opposite sides of a quadrilateral are equal and parallel, if the opposite sides of a quadrilateral are equal and parallel, then we can say that the quadrilateral is a parallelogram. So M and PQ is a parallelogram. So we can say hence M and PQ is a parallelogram. This is proved. Okay, friends, now let's check the second theorem. Theorem number 2, related to quadrilateral, we have the diagonals of a parallelogram bisect each other. Okay, so that means we have to prove that the diagonals of a parallelogram bisect each other. Okay, so we have the parallelogram. Suppose this is A, B, C and D, and we have the diagonals AC and BD. We have to prove that AC and BD bisect each other. Let's take origin here, O. We can take here as well, no problem. So position vector of OA, position vector of vertex A is OA, position vector of vertex B is OB, similarly C is OC and D is OD. Great. Now let's check. Now first of all, let's check the midpoint of AC. Okay, so vector midpoint of AC. Okay, position vector, solution, position vector of midpoint of AC is equal to, okay, position vector of midpoint of AC, somewhere here we have, if we have, then it is half of OA plus OC, right? It is half of vector OA plus vector OC. Now next we can say that this is also equal to vector OA plus vector OC divided by 2. Similarly, if I take the position vector of the midpoint, position vector of midpoint of BD, the diagonal, okay, BD is equal to half of the vector OB plus OD, vector OB plus vector OD, we can say that this is vector OB plus OD divided by 2. Okay, so these are the position vectors of the midpoints of AC and BD. Now let's see. Also, we say that since AB is equal to DC, AB vector equal to DC vector. Here, let's check why is this so. That AB and DC are the opposite sides of a parallelogram, and the opposite sides of parallelogram are equal. Hence, these directions are also same, AB and DC, so the vectors are equal. Okay, so AB vector equal to DC vector. And what is the AB vector and DC vector? Let's check. AB vector is OB minus OA, and DC vector is OC minus OD. Okay, so now I have AB vector is equal to OB vector minus OA vector is equal to DC vector is OC vector minus OD vector. Okay, so from here we can say, or now we can say that OB vector plus OD vector is equal to OC vector plus OA vector, and most importantly OB vector plus OD vector is equal to OA vector plus OC vector, and both sides we divide by 2. Okay, we divided by 2. We can see now OB vector plus OD vector divided by 2. Okay, and OA vector plus OC vector divided by 2 here, right? So what are these two vectors? These two vectors are the position vector of the midpoint of diagonal BD as well as the midpoint of diagonal AC. So from here we can see that the midpoints of these both diagonals AC and BD are equal. Hence, okay, hence the midpoint of diagonals AC and BD coincide. Okay, then only it happens. It means we can say, so the diagonals bisect each other. Okay, now let's see the next theorem. Our next theorem is the diagonals of a rhombus bisect each other at 90 degree, or the diagonals of a rhombus intersect each other at 90 degree, or the diagonals of a rhombus are perpendicular to each other. So now let's see how to prove this theorem. Okay, so I have a rhombus here. Let's say, suppose this is our rhombus A, B, C and D. This is our rhombus, and we have to prove that the diagonals AC and the diagonal BD intersect at right angle. That means this angle, okay, this angle, let it be the point P, intersecting point. So we can say that angle APB is 90 degree. Okay, so here we say that ABCD is a rhombus. Okay, therefore if ABCD is a rhombus, then we can say that AB equal to BC equal to CD equal to DA, because these are the adjacent sides of rhombus are equal. Adjacent sides are equal in a rhombus. Okay, now next thing what we have to do is we have to prove is that diagonals intersect at right angle. It means we have to prove that AC is perpendicular to BC, or we can prove that angle APB is 90 degree. Okay, so now let's see what we can do to prove this theorem. Now let's see the proof. We can say that vector AC is equal to vector AB plus vector BC. Vector AB plus vector BC by triangle law of vector addition. Okay. Similarly, what is BD? What is vector BD? So vector BD is equal to vector BC plus vector CD. This is also same as 1 by triangle law of vector addition, or we can say that vector BD is equal to BC vector. Okay, now check this CD, okay, is equal to AB, but the CD vector and AB vector are opposite and equal vector, so we can say BC minus AB vector. Okay, BC minus AB vector. Okay, so now let's find out what is the dot product of AC and BD. Okay, so now AC vector dot BD vector equal to AC vector is vector AB plus vector BC dot BC vector minus AB vector. Okay, so this is equal to, we can say BC vector plus AB vector times BC vector minus AB vector. From here we get BC vector square minus AB vector square, which is equal to mod of BC square minus mod of AB square. And we know that BC and AB are equal. BC and AB are equal. They are the adjacent sides of vector. So we can say that BC square minus BC square, which is equal to 0. The dot product of these two vectors are 0. Hence we can say hence AC vector is perpendicular to BD vector. Okay, so we say that the diagonals intersect at right angle. It means the angle between these two vectors, AC vector and BD vector, is angle APB, so it is 90 degree. Okay, so angle APB is 90 degree. It is also proved. Now let's check the next vector. Next theorem is prove that the diagonals of a rectangle are equal. So let ABCD is a rectangle and the diagonals are AC and BD. We have to prove that AC is equal to BD. Okay, so now let's see from here. Let's try to understand that in a rectangle, okay, ABCD is a rectangle. It means AB is equal to CD and BC is equal to AD. These are the opposite sides of rectangle. And another thing, we should know that these vertices are 90 degree. It means AB is perpendicular to BC as well as BC is perpendicular to CD. All these things we should understand, that BC is perpendicular to CD and so on. Okay, these are the basics we should understand about a rectangle. And now let's move to prove our theorem. Our theorem is the diagonals of a rectangle are equal. So first of all, let's see what is vector AC. Vector AC is equal to vector AB plus vector BC. Vector AB plus vector BC. Okay, this is by triangle law of vector addition. Okay, now let's check what is vector BD. What is vector BD? So vector BD is also equal to vector BC plus vector CD. Vector BC plus vector CD, and we can see that vector AB and CD vector, these are AB and CD are equal, but the vectors are opposite in direction. So we can say that vector BC minus vector AB. CD is opposite to vector AB, so CD is equal to negative AB. Okay, this is also by triangle law of vector addition. Okay, let's mark this equation as 1 and this as 2. Okay, so from 1 we have AC vector is equal to AB vector plus BC vector, and squaring both sides, AC vector square equal to AB vector plus BC vector square, and squaring both sides we get vector AC square equal to vector AC square is equal to vector AB square plus 2 times vector AB dot vector BC plus BC vector square, and this is equal to vector AC square equal to AB square plus 2 times 0. AB dot BC is 0 because vector AB and vector BC are perpendicular vector. Okay, AB is perpendicular to BC, that's why. So product of perpendicular vector dot product of perpendicular vectors is 0 plus vector BC square, and finally vector AC square is equal to vector AB square plus vector BC square. Okay, so now let's mark it as number 3 and check what is number 2. Number 2 we have BD vector equal to BC vector minus AB vector. Okay, BD vector is equal to BC vector minus AB vector. Now let's square both sides. We get BD vector square equal to BC vector minus AB vector square, that is equal to BD vector square equal to BC vector square minus 2 BC vector dot AB vector plus AB vector square, and we know that BC and AB are perpendicular vector and the dot product of perpendicular vector is 0. So BD square equal to BC square minus 2 times 0 plus AB vector square, and BD vector square is equal to AB vector square plus BC vector square. Now we can see that the equation number 3 and equation number 4 are equal. It means AC square is equal to BD square. Okay, so we say from 3 and 4 AC square is equal to BD square. Okay, AC square is equal to BD square. It means the mode of AC and BD, means the magnitude of AC and BD is equal. Hence AC equal to BD. Okay, therefore diagonals of a rectangle are equal. This is also proved. Now let's take the last theorem of this session. Our next and the last theorem is the angle at the circumference of a semicircle is a right angle. Okay, so now let's see. We have a semicircle here. Okay, we have a semicircle and the center of this semicircle is O, and this end point of diameter is AB. So somewhere here we have a point C, and we're going to join this point AC and BC. We have to prove that this angle ACB is a right angle. Okay, so now we have that ACB. Okay, ACB is a semicircle. Okay, and we have to prove angle ACB equal to 90 degree. Okay, ACB is equal to 90 degree. Now let's join OC here. Okay, let's join OC. Now proof join OC. Okay, now let's see what is vector BC. What is vector BC? So vector BC is equal to vector OC minus vector OB. Okay, vector OC minus vector OB, take as 1, and now see what is vector AC. Vector AC is equal to vector OC minus vector OA. Okay, and here now let's see OB and OA are equal. These are the radius of a circle. Okay, but OB vector and OA vector, they are equal but opposite in direction. So it means one is the negative of other. Hence I can say vector OC minus negative of vector OB, because they are equal being the radius of a circle, and OC vector plus OB vector. This is number 2. Now let's see the dot product of these two. Okay, so I have BC vector dot AC vector is equal to OC vector minus OB vector dot OC vector plus OB vector. So now we can see that A minus B times A plus B is equal to A square minus B square. So OC square minus OB square. Okay, so it is the mode of vector OC square minus mode of vector OB square, where we can see that OC and OC and OB checked here. OC and OB, these are also the equal. These are also equal because they are the radius of the same circle. Okay, so we can see that mode of OC square is equal to mode of OB square. Okay, being radii of same circle. Okay, so we can see that this is equal to 0, and the dot product of BC and AC is 0. Okay, it means the angle between these vector is a right angle. So AC dot BC is 0. It means the angle between these vector is ACB, which is a right angle. Okay, so we say hence angle ACB is equal to 90 degree. Okay, and this theorem is proved. Friends, if you like my video, don't forget to subscribe to my channel and comment